Hello, today we're going to be covering section 1.2, which is on the composition of functions. What the composition of functions basically means is that you are going to combine different functions in different ways. So as you can see on the screen, I have 4 different functions listed. So we can combine 2 different functions, say f of x and g of x, using addition. We call that the sum. We can subtract f of x and g of x. We call that difference. We can multiply f of x and g of x. We call that the product. And we can divide f of x and g of x. We call that the quotient. Now the order does matter. If they say f plus g, that's different possibly than g plus f, and so forth throughout all the different types of composition of functions. Now one important thing to note, and this goes back to domain, is that g of x cannot be 0. And the reason why g of x cannot be 0 is because it is on the bottom of the fraction. And if you have some number divided by 0, we know that that causes what mathematicians would call an undefined situation. We don't want undefined situations. So we need to note what g of x what value of x, when put into g of x, would cause it to be equal to 0, because we don't want to put that into the function. Alright, so let's put these into effect. Take a look at an example here. So here we have a function f of x. F of x is equal to 3x squared minus 4. And we have a function g of x, which is 4x plus 5. And we are asked to find different compositions of functions. In part A, we have f plus g of x. As defined above, the sum property says that f plus g of x is equal to f of x plus g of x. Okay, so all we're going to do is take all of f of x, 3x squared minus 4, and all of g of x. You can put g of x in a different color. Let's use, let's say red. So g of x plus, and I like to put functions in parentheses, and I apologize, I forgot the parenthesis on f of x. And we really should say that. So we're putting f of x, which is in blue, and we're adding g of x, which you can see as in red. Okay, so for addition, it doesn't really make a difference when you add something. Okay, so the parentheses here can be dropped for f of x. So you have 3x squared minus 4. And when you're adding both things. So it's plus 4x plus 5. 5 does not really change how 4x and 5 is added. Now we're going to combine like terms. So 3x squared, there's only 3x squared. There are no other x squareds to combine with that. So we have 3x squared. Then we look for the next lowest power, which is x. So that's plus 4x. And then the next lowest power would be no x's. And we have a negative 4, and we have a plus 5. So when we combine those two, that gives us a plus 1. So f plus g of x is equal to 3x squared plus 4x plus 1. That's the new function that we created by adding f and g of x. Okay, so we're going to start over, and we're going to do the same thing for f minus g of x. Okay, so again, I'm going to put the f of x in blue, the g of x in red. Okay. So f minus g of x is f of x minus g of x. Again, I'm going to put f of x in parentheses, 3x squared minus 4. Put g of x in parentheses, 4x plus 5. So in the last example, when we added, we had to distribute the addition. Same will be here. The first set of parentheses, there's nothing to distribute, so we simply have 3x squared minus 4. But here we have a minus sign, and that minus sign needs to be distributed. It means it needs to be put to everything inside of the parentheses. So we have minus 4x minus 5. Again, combining like terms, highest power to lowest power, 3x squared minus 4x. And this time we have a minus 4 and a minus 5. Combining those, we have a minus 9. So f minus g of x, completely new function that we created, is equal to 3x squared minus 4x minus 9. Okay, let's take a look at the next one. Next case, we have f times g of x. We're going to use again the same f of x and the same g of x. So f times g of x is f of x times, which we often use a dot to represent multiplication, times g of x. Okay, so in parentheses, 3x squared minus 4, parentheses, 4x plus 5. Alright, so we have a multiplication. And anytime you have a multiplication with two sets of parentheses, we're going to distribute. Okay? Some of you may know it as factoring, when you multiply a two-term binomial times a two-term binomial. And that's what binomial means, two terms. You could use what's called FOILing. I believe I said factoring. I apologize. I meant FOILing. So FOIL means you multiply the first two things together, and that's all a distribution is. So you're taking 3x squared times the first term. So 3 times 4 is 12, and x squared times x is x cubed. When you multiply, you add the exponents. And then we distribute the 3x squared to the 5. So that's plus 15x squared. And then we'll do the same with the negative 4. So the negative 4 gets distributed to the 4x. So that's minus 4 times 4 is 16x. And then we're going to distribute the minus 4 to the 5. So we multiply those together, we get negative 20. And then we would combine like terms, but in this case, there are no like terms to combine. Again, you look for the highest power first, which we have x cubed. There is only one term with x cubed in it. Then x squared, there's only one term that has x squared. And then x, again, only one term. And then a term with no x in it, the number negative 20. So there's nothing to combine, so we're done. This is the new function f times g of x. That's what you get when you multiply f and g together. Alright, let's finish up by multiplying. I'm sorry, I said multiplying. By dividing f and g. So f divided by g of x is f of x divided by g of x. Okay, so if I go back, I can see what f and g are. So f of x, as you can see down here, is 3x squared minus 4. And g of x, 4x plus 5. And again, I am putting parentheses here. Parentheses is very helpful when you're adding and subtracting and multiplying. It might be helpful when dividing, but in this case, when you're dividing, they simply just go away. They do not really have any effect on this division. So our new function is 3x squared minus 4 over 4x plus 5. Now, the top term is a quadratic, and we should think about whether or not that quadratic is factorable. Looking at it, from my experience, it's not looking like it's factorable at all. If it was factorable, we should look to separate it and see if we can divide something out, or if you have something over itself, it would cancel out. But I don't think there's any way that we can factor 3x squared minus 4 and end up with a 4x plus 5 to cancel that out. So we're going to call this complete, but we must note where there would be any issues. And the issue that we talked about earlier was that g of x is not allowed to be 0. Now g of x is right here. 4x plus 5 cannot be 0. So when we set up this little inequality, we can solve for x, and that will tell us where g of x will not be equal to 0, or cannot be equal to 0. Because if we did put that number in, it would cause a 0 on the bottom, and that would be an undefined situation, and we don't want an undefined situation. So in order to figure out what x value would give us a problem in the bottom, we simply just solve for x. So as you can see, I subtracted 5 over, and now I'm going to divide, and I get negative 5/4. So we have to note that x cannot be negative 5/4. Okay, and that should be part of the solution. Okay, so we'll just put like a little comma here. So comma, x cannot be negative 5/4. So we have to tell someone that this is a bad idea to put in negative 5/4 in. Because if we did, then we would get a 0 on the bottom, and that would cause an undefined situation, which we do not want. Alright, so we've added, subtracted, multiplied, and divided two functions. And we've used f of x and we've used g of x. But it could be any two functions. It doesn't have to be f of x and g of x. It could be any letters that we use to represent functions. It could be p of x. It could be q of x. So don't get stuck on f and g. I've seen other like r of x. So h of x. So it's just a matter of combining two different functions using addition, subtraction, multiplication, or division. Now, we run into a special composition of functions. As you can see here, the symbol looks like FOG of x, fog of x. So that's not really what it means. It's just an open dot. So if I was better at writing this, it would look like a big F, a little open dot and a big G. Okay, so still kind of looks like fog, but the dot is not as large as an O, but it's F open dot G, or F of G of X. And this is how we write that. F of G of X ends up being a substitution problem. So we're actually going to put the function, the G of X, the whole G of X, into the function of F. And it's going to replace the X variable. Okay, so this is a substitution. I think it would be best explained if we jumped into the example and took a look at that. So here in this example, they want us to find F of G of X and G of F of X using these two functions. And here we have F of X, and over here we have G of X. So F of G of X, okay, is going to be F parenthesis G of X. Okay, so we're just going to make a substitution. So as you can see, this is G of X, and I should have wrote G of X in red. Let's go ahead and do that. So G of X, that's our function G of X in red, as you can see up here. So all I'm going to do is replace G of X with what it's equal to. Well, as we can see up here, G of X is equal to 5x minus 6. So I'm going to put that in. 5x minus 6. Yeah, so that kind of looks interesting. So we have F parenthesis 5x minus 6. So F of G of X is now F of 5x minus 6. So that 5x minus 6, that whole thing, is going to be put into F of X. Now where is it going to go into F of X? It's going to go in everywhere you see an X. Okay, so what's this equal to? So this is going to be equal to, instead of an X, I'm going to put in this, parenthesis, 5x minus 6 squared. And it's going to say minus 3, and instead of x, I'm going to put in, parenthesis, 5x minus 6, then plus 8. Plus 8. Squeeze it in there. So my function is now 2 times 5x minus 6 squared minus 3 times 5x minus 6 plus 8. So that is what F of G of X is equal to. Okay, that's creating a new function. So I'm taking G of X and I'm putting it in for all the X variables in F. Now once that's done, this is technically F of G of X. Okay? But it's not simplified. So we need to simplify this out. Okay? And hopefully everybody understands that an exponent simply tells us how many times we're going to write whatever the exponent is raised to. So I have a quantity right here of 5x minus 6 squared. So I'm going to write quantity 5x minus 6 twice. Minus 3, 5x minus 6 plus 8. Alright, so now when we multiply, we mentioned this earlier, you can FOIL, which is just a distribution. I'm going to take 5x times 5x, and I'm going to take 5x times negative 6. So 5x times 5x is 25x squared. 5x times negative 6 is negative 30x. Okay, and then we do the same with the second part. So the negative 6 gets distributed to both. So negative 6 times negative 5x is negative 30x, and negative 6 times negative 6. Two negatives makes a positive. 6 times 6, 36. I can distribute the negative 3 to my next quantity. So that's negative 15x. Two negatives again make a positive. 6 times 3, 18. And then we have a plus 8 on the end. Alright, let's clean this up before we distribute. So we're going to combine like terms. 25x squared minus 60x. So again, when you're combining like terms, when you're adding or subtracting like terms, you add the same variable with the same exponent. So I'm looking for any x squareds. I only have one inside of this parenthesis. That's all we're looking at right now. Just what's inside this parenthesis. I have a negative 30x and a negative 30x. So that gives me a negative 60x. And then plus 36, because that's the only number. And then I can combine what's left outside. Negative 15x. There's nothing to combine that with. But I do have a plus 18 and a plus 8. So plus 18 and plus 8 ends up being plus 26. Okay, so let's finish this up. We're going to go ahead and distribute the 2 now. Okay, now when you distribute every single term. So $50x squared minus 120x plus 72 minus 15x plus 26. So 50x squared. Here we have 120, negative 120x, negative 15x. That's negative 135x. We have 72 and 26. That's plus 98. So that is f of g of x. And the last part, we go back up and look at what we were asked to do. I did f of g of x. And now I would like to see g of f of x. Okay, so actually I'm just going to wipe this out and start over. Alright, so here's my f of x, here's my g of x. Now we want g of f of x, or g of f of x. So instead of g of x being on the inside, the second letter f of x will be on the inside. So where is f of x? Well, f of x is what I have here in blue. So I'm going to replace what f of x is equal to. 2x squared minus 3x plus 8. Okay, so here's where our substitution occurs. So whatever letter is out front, so this is g this time, okay, we're going to go to g, okay, and everywhere there's an x variable, everywhere there's an x variable, that's what we're going to replace all of this with. So here's my g of x. It's 5, but instead of writing x, I'm going to write 2x squared minus 3x plus 8, and then minus 6. So as you can see, the x in, okay, the x in g of x is being replaced with this entire function f of x. And then we just clean that up. We can distribute. We get 10x squared minus 15x plus 40 minus 6. Combining like terms, any x squared terms, just the 10x squareds. The x, only the minus 15x, and the plane numbers, I have 40 and negative 6, so that's positive 34. So that's g of f of x. Okay, last we are going to talk about the domain of f of g of x. The domain of f of g of x can be found by looking at the final result and determining if there's any issues. Now, if you can remember back to domain and range, domain, there are two problems with domain. So two problems in domain. Okay, number one, fractions. Okay, and with fractions, you cannot have any, bottom can't be 0. Okay, and number two, square roots. Okay, under square root has to be greater than 0. We cannot have negatives underneath square roots. Okay, if you remember back to the 2, if you have a negative under a square root, that causes what we call a complex number, an I, and we only are interested in the real solutions right now. So we would definitely want to stay away from imaginaries. We want to stay away from undefined situations. So let's go ahead and create f of g of x. So f of g of x is written as f parenthesis g of x. So again, the g of x is on the inside. Let's go ahead and switch that to a different color. So g of x, here's g of x. So that's what we're going to put in. Here we have f 1 over x squared. Now to finish this problem, well, we can now talk about the fraction that we have a problem with. So when we're putting that in, that's going to be something we need to talk about. The bottom cannot be 0. The bottom of the fraction is currently right there, x squared. So if I take the square root, or what number times itself would be 0, okay, that's going to be 0. So right now, x can't be 0. Okay, now we're going to put this into f. And remember, when we put it into a letter, we put it in for the variable x in that letter. So we have square root. Here's our 1 over x squared minus 4. Oops. That didn't turn out very well. 1 over x squared minus 4. Okay, so this is our function, and we could clean it up a little bit. We could combine the fractions if you wanted to. So it would be 1 minus 4x squared over x squared. So as you can see, we still have the x squared on the bottom, so that's why this restriction, x can't be 0, is still good. We'll go ahead and leave it like so. That's your f of g of x. But we have another issue, and that issue is that this, either this form or in this form, is underneath the radical. And whatever's underneath the radical cannot be negative. So we have to say that 1 over x squared minus 4 has to be greater than 0. Solving for x, we get 1 over x squared is greater than 4, or 1 is greater than 4x squared, or 1/4 is greater than x squared. Square rooting that, what times itself will give you a quarter. That's a half. So when we're all said and done, besides the x can't be 0, we also have to say x is less than 1/2. So, what's the domain? All right. The domain comes from x can't be 0, and x has to be less than 1/2. So, that's all we're going to say. We're going to say there's no nice way to write that. So those two together is going to make the domain. So let me clear this out a little bit so we can write the domain. For the domain, which we usually represent as d, d is equal to x less than 1/2 or x cannot be 0. Okay, so there's really no nice way to write that. And this is in what's called set notation. It's basically saying that you can't plug in something less than 1/2, and you definitely can't plug in 0. Now, do we really have to say x can't be 0? Because I think that's no, we do have to say that because we're saying that we can plug in things less than 1/2. That's when it works. Okay, so this is our domain. Last problem. Again, this deals with substitution. Composite function, f of g, g of x, a lot of substitution, even with the addition, subtraction. We're just simply making lots of substitutions. So here's another interesting problem with that, and it's called an iterate problem. Okay, iterates is basically a way to solve problems. A long time ago, mathematicians didn't have all these formulas, so what they did was they guessed. So they would guess what the answer is, and they'd plug that in, and they'd get a solution, and then they'd guess again until they actually were able to pinpoint the actual solution for more difficult problems. So the iteration process is simply just a substitution. So we have f of x, we have a function f of x, and then we have an initial value. This is our guess, x sub 0. So all we're doing is just finding what f of x would be. So here's how it works. To find f of x sub 0, that would be equal to x sub 1. So to find the first iterate, you plug in the initial value x sub 0 in for x. Okay, well, what would that be? Well, f of x sub 0 is f of 1, or 2 times 1 minus 3, 2 minus 3, negative 1. So, x sub 1, or our first iteration, would result in negative 1. And guess how you find the second iteration? You simply say, find x sub 2. I'm going to find what f of x sub 1 is. We're just going to plug that answer in. F of x sub 1, we just said was negative 1. So we're putting negative 1 in for the x. So 2 times negative 1 minus 3. Negative 2 minus 3, negative 5. So x sub 2 is negative 5. And to find x sub 3, you're just going to find f of x sub 2. So f of x sub 2 is negative 5, or 2 times negative 5 minus 3. Or negative 10 minus 3, negative 13. So the third iteration is x equals x sub 3 was negative 13. Second iteration was negative 5. The first iteration was negative 1. And hopefully we'd see a pattern in these iterations, and that would allow us to solve more complicated problems. And that's all we have for this recording.